Welcome to Beyond Tech, where innovation meets insight.
We're your hosts, Jennifer Palumbo and Jackie Slaght, and we bring curiosity, clarity, and a passion for technology-driven storytelling to every conversation. This episode is about the impact and importance of the critical, but often overlooked, clean-in-place system. And we brought in experts Hans Frei and Jeff Ballard to discuss more.
Hans Frei is the Director of Engineering at eTech Group. He's a licensed professional engineer. Hans brings a deep expertise in automation and controls with a strong focus on batch control, CIP optimization, and system integration for pharmaceutical and life science clients. He's known for aligning automation strategies with regulatory and operational goals, making him a trusted leader in the field.
Jeff Ballard is a business development manager and seasoned automation professional with a proven track record in modernization, Industry 4.0 adoption, and large-scale project leadership. Jeff brings a broader industry perspective, including deep experience in water and wastewater, OEM, and end-user environments, all of which benefit from smarter CIP strategies. CIP systems are essential for maintaining product safety and quality, especially in regulated industries like pharmaceuticals, food and beverage, and life sciences.
So, Jen, I was able to sit down with Hans and Jeff, and I really enjoyed learning from them about the impact of CIP optimization. With CIP optimization, clients can experience 30 to 40% shorter cleaning cycles and save up to 50% on their water and chemical usage, which is a huge impact.
Yeah, I was sorry to miss the initial interview with Hans and Jeff. I know they both have a lot of experience in this area, and I've worked in system integration and in industry pretty much my whole career, and I knew of Clean in Place, but I really didn't know of the impact that it could have on process like that. I mean, 30 to 40% impact on cleaning cycles, or using up to 50% less water and chemical usage. I mean, that's a huge savings to clients just by a simple process optimization.
Yeah, like I said, it was a really insightful conversation, and like I said, Jeff and Hans are both were great to talk to and explaining it, because I didn't know a lot, and now feel like I have a new appreciation for what manufacturers go through to keep the products obviously safe and the lines running, but to have such a critical system that can make such a big impact was insightful.
Yeah, agree. I think anybody in process manufacturing is going to benefit from this conversation.
Yes, well, I hope you guys enjoy. So, welcome, Hans and Jeff. Thank you guys for being here today. Can you take a quick second before we get into too much about Clean in Place and just introduce yourself and tell me, how would you describe your job to a 5-year-old child?
Yeah.
Do you want to take it first, Hans?
I will take it from here. So I'm the Director of Engineering for our Modesto, California office. And so I help manage the engineering leadership team. And then also I look over the manufacturing team here in this location. And so my best description for somebody trying to understand what we do, because it is usually can be complex and have a lot of parts, but the easiest way is that I give machines their brains.
I love that answer. I think that's great. Jeff, can you introduce yourself real quick and how you describe what you do to a child?
Yeah, I'm Jeff Ballard. I am Director of Business Development. I have a super fun job because I get to work with everybody. Plus, I get to be in the field and see all the interesting projects. And the way I tell everybody is there's a show out there called How It's Made. And I get to go out and help people fix their plants. Everybody from Tesla all the way to Sierra Nevada Brewing Company to Intel.
Well, that sounds like a job that keeps you on your toes, doing all kinds of different things. So thank you guys for both being here today. Now that this episode is focused on Clean in Place systems and how to optimize them. However, I think before we get into that, Hans, can you explain a little bit what is a Clean in Place system for anyone who who may not know.
So a clean in place system is a dedicated skid or part of the system that only cleans the production equipment. So instead of having to disassemble the whole equipment every time to hand clean all the pieces that can be part of a system, they have a dedicated skid or part of that system that will be able to deliver rinse fluid and wash fluid and manage that part of the process. So then they can keep it all intact, run the system in an automated fashion to be able to clean it be either between different types of products or based on the spoilage capability of the product, so that when they run that production system, it is pristine and ready for a clean production run.
I imagine that's really important in like food manufacturing facilities as well as life sciences. Is that pretty accurate?
Yeah, both of those, anything that deals with any type of consumption for humans, like either that be both medication, food, or beverage products, are going to need to have some sort of clean in place to be able to get that equipment into a state that is not going to spoil or contaminate that production material, so they can then, get it out there for us to consume.
I think that gives a pretty good overview. Jeff, do you have anything else that we've missed?
Yeah, just to add to that. So think of it this way. In the Central Valley of California, there's around 25% of the food for the nation comes out of here, right? So that's tomatoes, rice, garlic, strawberries, lettuce. And those systems, the CIP systems, are what clean all those machines that process what we would call food and beverage processing. So very, very important systems.
Yeah, no, thank you. That's great. So you kind of hit on this, but let's just go into it a little bit more. But why are the clean in place systems, they're such a critical process? Why are they often overlooked in food and beverage? And I heard also that they can sometimes be made overly complicated in the life science industry. I guess generally speaking, I can't speak to every plant, but
Yeah, so a lot of times a production system is built with a very certain set of criterias. And so those criterias for production may not be the same criteria that needs to be in place for the CIP side. So the system is made to produce a product, so they're going to design that system to meet that requirements. And so they'll have to add a CIP portion to there to be able to make sure it's clean. Well, sometimes those different requirements may be in conflict with the production. So they will more likely generally get that CIP system to pass its cleaning cycle so that the quality can give it the okay that this system has been properly cleaned. But instead of going through the same process to make sure that it's optimized, all the consideration or time for that optimization had been dedicated to the production portion of that facility. And so when they get the okay, hey, it passed, then they don't leave the CIP system or they leave the CIP system alone and not worry about trying to make it perform as well as it possibly could. And then on the life sciences side, talking to a colleague recently, there could be an over complexity of the CIP system to kind of be extra sure that it cleans. And so then they add all these different layers to it when in reality you could look at what it's trying to do and then see, well, I don't really need to do this extra step or this extra phase because it really doesn't gain me anything into that system. And so they overcomplicate it to have that extra assurance that it's doing what it's supposed to do, rather than kind of looking at it more of a simplistic mindset of like, what does it just need to do? And then making sure that it does that, obviously with a certain level of repeatability in there, but not, if a rinse needs to be 5 minutes, not take it to 20 minutes, right? And so those are some of the things that can be done that reduce the optimization of a CIP system.
Yeah, thank you. That helps a lot. So and again, I think we kind of hit on this, but why have CIP systems historically not been optimized? Jeff, would you like to?
Yeah, good question. It's sort of a oversight or what we call an afterthought, but keep in mind this. They're part of the safety and cleaning, but in a large facility, any small inefficiency it goes into the dollar category, right? So a couple times with some large end customers, we've tightened up the efficiencies of those CIP systems and other systems. So if you think about inefficiencies over a whole year, that saves a lot of dollars at the end of the year. And not only that the system just runs better.
Hans, can you elaborate?
Yeah, kind of just continue on it. Because it passed, they don't seem a need to have to improve that efficiency. But over time, there could be additional loads being placed on that CIP system, or maybe the production run needs additional time or needs an additional output. And now they're trying to look for ways to improve that efficiency of the facility. But the CIP system, for whatever reason, may not always be a pinpoint that they look at specifically to gain some of that efficiency back, because they're either maybe because they view it as a quality item, or because they don't know what the CIP system actually does, or they're worried about it meddling with it, that it breaks entirely. And so there's times where it just kind of, it almost thought it was like a utility and you just don't touch it. But in reality, there can be a lot of stuff that can be accomplished by looking at your CIP system and understanding what it does, where it may be not performing as well, and also ensuring that it is actually capable of handling maybe some new production additions to make sure that your CIP system can handle that expansion to your facility.
Okay, so if there is a facility that maybe they set the CIP system for for the line at one point, it passed, then if they upgrade the line, does it have to go back through another review to make sure that it still is working, or is that like it passes once and it's good forever?
It kind of varies by different industries. Some industries have higher level of regulation that they have to achieve by. And so in some cases, they have to have proven reports that they ran the CIP and then identify why it didn't finish or why did it stop in some of those cases. But in general, I think just having a normal cadence within a facility just to look at your CIP to make sure that it is actually passing. So you don't get in this vicious cycle of, oh, it didn't pass, so we'll run it again. And then like, okay, from now on, we're going to run it 2 times. And then it didn't pass after 2 times. All right, we're going to always just run it 3 times, And so you can bake in a huge amount of time loss in the facility by just trying to get through it rather than understanding what the root cause on that CIP system is and why it's not performing properly.
Yeah. So I know just from my outside knowledge, working in the industry from a marketing standpoint, that downtime can be so critical. So I imagine if it doesn't pass and they just run it again, but it does pass, they're like, well, cool, we can just keep going, instead of, like you're saying, kind of getting to the root cause of why is this happening and how can we fix it long term. So, okay. Thank you for teaching me. So I, again, kind of staying on this same path, why is it more important than ever now for companies to look at prioritizing the CIP optimization?
So being in California, water is always a very critical item that all facilities have to make in consideration. So if you have a CIP system that, say, maybe you're having to run 2 or 3 times to just pass a single wash, imagine the amount of water that facility is going to have to consume. And then that same water, because it is a washing, they can't use it for production, so they're going to have to dispose of that water. So now they have 3 times the amount of water that they're consuming and disposing of to be able to just do a single type of function or circuit within their CIP system. And so on top of that all, then you have your washes where you have a chemical addition as well. So now you have a chemical cost that you're going to associate. So if you have a very inefficient CIP system, you could be consuming far more chemical than you actually need in that circuit or skid to accomplish what it is set to do. And so that's a huge cost that it has. And then the thing that then everyone thinks about is time, right? And so if your CIP system is taking more time than it should to complete a circuit wash effectively, now you're losing that time to production, which production is what makes you your money. CIP doesn't make you any money. It's the production that is. So if CIP is consuming production time, now you're not able to gain that revenue back by the production that you're making within your facility.
That makes sense. Jeff, do you have anything to add?
Yeah. So remember that the scary word in production is downtime, because downtime is lots and lots of dollars. So these systems, again, a lot of the end customers, the large end customers that we go into, they're either expanding their facility, they're retrofitting their facility, they're doing what's called a modernization, and that affects the CIP system as well. So the CIP system has to be updated as well. And then that falls into things like EHS, right? So environmental health and safety and FDA things. So again, it's sort of a not so looked at system, but incredibly important.
Yeah. So again, let's keep going down this path. What are some of the most common inefficiencies that you see in a traditional CIP system?
The ones that I've seen is the quote that I've heard is dilution is a solution, which is not the case. So we can always, clean something by just hitting it with more water and more chemical and more water. But if you were to take your system and look at it as a liquid management, it's like, so how am I managing this liquid as it passes through this set of pipes or equipment, and making sure as I'm in control of this liquid movement through that circuit, and be very specific on how I want it to move through my circuit. Now I can look at how I can either, make my rinses extra efficient, or how I can make sure my washers are set up so that I don't have too much fluid and adding more chemical than I need. And so understanding that the core principle of your CIP is fluid management, and how it moves and how it gets transferred from one part of the system to the other. When do I drain it? When do I retain it? And et cetera. And so that understanding typically governs on all the different facets that can be done to improve the efficiency of a CIP system.
Jeff, do you have anything to add to that?
Yeah. So a couple of the projects we've worked on are, we actually automate the CIP system where we can help them tie that CIP system into their SCADA and actually automate reports, so that when they turn in reports, or if they're asked for reports, or if they're asked for the efficiency of their CIP, it's basically automated, and it's something that can be spit out of the SCADA or the plant-wide SCADA system, just automated and automatically.
Okay, thank you. So I guess now we kind of have touched on a little bit of what the CIP is and how it can be inefficient, but wondering for any listeners out there, how could they improve their system or tell if their system is in need of optimization?
So if you have an automatic type CIP, the end goal is that it runs without a lot of operator interaction with it, right? You set it up in the beginning, you hit start, and typically it should be able to run through its steps with a lot of interaction. So if your CIP is requiring maintenance or operations to be present almost the entire time, because it will randomly stop working or won't be able to continue through its steps. That's a clear indication that there's something not happening quite right. The other two is if you don't even know what your CIP system is doing, what circuits it's capable of washing, or what steps it has, what phases it's trying to accomplish, just that knowledge itself can help alleviate some of that diagnostics that maintenance or operations will have to go through in there. And so another big key is like you get stuck on a step and no one knows why. There's no information from the system as why is it stuck. And then you'll sit there and look at it and try to figure it out. All of a sudden, out of nowhere, it'll just move on. So that's also usually a very big indication that something's wrong. Or kind of like what I alluded to before is like, hey, we figured out a fix, but is it really the fix or is it just a Band-Aid? You know, we can't get past this step because we don't have enough chemicals. So we add a little bit more in and add a little bit more in until it finally reaches some unknown set point, and then the system progresses through. So some of those kind of a lack of knowledge on your system is probably your biggest key, that maybe there's something that's not right, but then just it's not functioning as an automatic type of system, which that's what we're in the business of doing, is making stuff automatic.
Yeah. Anything else, Jeff, that you want to elaborate on or expand on?
Yeah, usually the CIP systems are made by a third party or another company, right? And they come in, and a lot of times when we're in the field, we'll say, hey, what's going on with that system over there? Or how's your CIP system? And a lot of times they'll say something like, that's never worked right. I don't know. And they're kind of frustrated with it. And we can actually come in and say, hey, why don't you have us come in for a couple hours, run the system, and have us take a look at it and evaluate it. And usually that's kind of what alleviates some of the challenges of those systems.
Yeah. How long? I know in some industries, some of the equipment that we go in to work on is very old. How old are most CIP systems? Is there an average age?
No. It could be old as the facility, or it could be brand new because it came already pre-equipped. But yeah, it's across the board. It is a mixed bag. I don't know if I could say I've seen it all around the same age.
Okay.
Yeah, legacy systems are a big part of our job, right? So we call them legacy systems. Remember that, when an automation system comes in, they normally don't touch it. They just leave it alone and they'll let it sit there. And there's some automation systems that are out there that are 30, 40 years old, right? So older than you, Jackie. And so part of our job is to go in there, support those systems, and then say, hey, what's your plan for that? There's no parts for that. And they go, I don't know. And that's where we come in and help them plan out how to upgrade the old CIP systems.
Oh, yeah. So I guess then going to the opposite end of the spectrum, what role does data play in the modern CIP system?
Yeah, this is a great question, right? Because our plants now are more and more involved with their data, right? So every machine, every system produces data. We can pull that in through data collection, through what's called a historian in SCADA, and we can help them squeeze yields and also eliminate downtime, or get to the point where they realize why they're getting downtime. Huge time and money savings.
Hans, can you elaborate?
Yeah, I've seen some facilities.
Yeah,
I've seen some facilities even go to this measure of having predetermined text responses on why a system has stopped, and be able to go directly inform their maintenance team, hey, this CIP system has stopped and this was the reasons why. And then they can go and address that directly on the next available shift, instead of allowing that to just continue on and on and on indefinitely, and have a problem child essentially within your facility. And so the other thing too is, if you don't always know that your system is not functioning good, because you don't have the data of when it was doing good. And so having that benchmark with that data, and you can see if something like your like your heating step has suddenly gone from originally 5 minutes to now 50 minutes. Like, but if you never had that data before, no one's going to necessarily remember that it only took that tenth of a time. But now you can have data acquisition to show that, and you can reference that and be like, wow, now it's 50 minutes. That's not right. And then be able to then align the team on trying to figure out a root cause.
Data doesn't lie.
No, always more data is always better, I guess, if you know what you're looking for. Sometimes if it's just data to have data and you're not doing anything with it, it's not as effective. So I think this, you may have already touched on this, but I'll just ask anyway. Are facilities using these analytics and tracking KPIs to improve their performance over time?
They are definitely for production, but CIP is one of those ones, like, they're not realizing that they can have the same effect with the same KPI type of data that they apply to production. They can apply the same type of metrics to their CIP skids, because it's an automated system. It's just not a straight utility. Like, it's not just water delivery or steam delivery or their electricity. It's actually a controlled mechanism that they're in charge of within their facility, that they can gather information and create reports that are meaningful to them.
Yeah, KPIs are across the board, right? So you're going to get, with 10 different conversations, you're going to get 10 different answers, right? And some manufacturers are great at using and setting KPIs, and other ones, they have the data, but they don't know how to utilize it. And again, that's where we come in and sit down, take a look at that data and help them set up KPIs and increase production. Again, lower downtime, lower resources that they're using to try and keep the system running.
Yeah. So then, kind of going off this, do you have any real world examples of where CIP optimization led to measurable results, and for the client?
Yeah, an opportunity working with a food and bev system. They had a brand new state-of-the-art system, and I was helping them out with the production side. And then I just asked them about the CIP portion of it. They're like, yeah, it takes a long time to run. Sometimes they have to run it 2, 3, 4 times before it actually will pass their CIP requirements from their quality side. And so I'm like, oh, that's interesting. Mind if I take a look at it and see if there's anything that I can recognize that might be causing these issues on your system. And so I went through and completely documented all the steps that were involved. It was a multi-tank facility with quite a few extra little branches here and there along the line. And so I went through and found out the CIP should take about an hour to run. It was taking closer to 2 or 3 hours to run in its current state. And so I said, Kate, can I restructure this sequence to what I think will be more meaningful for the skid? And I guess, sure. So I restructured the steps and the order of the steps. And mind you, we didn't change anything as far as actual physical parts of the system. It was just looking at the logic and understanding how that logic flowed and that fluid management, how it flowed using the valves and the pumps and the tanks and the piping that was already in place. And so, and essentially in the state I found it was pretty much taking an entire shift to run through a CIP. So they were losing that shift every time they run a CIP that they were not able to do production with. And so after we had gone through that, applied those changes that I saw were necessary. One is that they were dirtying their system after it had already been cleaned. They were then reintroducing dirty water back in, and then take that CIP to go through one sequence in just about an hour's time, and we got it to where it would pass on the first time through about 90% of the time. So they went from almost never being able to pass on the first cycle. And that extra 10%, they had some pretty fragrant flavors that were part of that system that were required a little extra oomph on occasion when they run that particular product. That's why that extra 10%, they didn't always pass that first time, because it was they had to remove that fragrance for their productions. but they went from an on average 6 to 8 hour CIP time to 1 to 1.5 hours. And just that alone, they were starting to have concerns about being able to meet production. By changing that CIP, they were able to always meet their production demands. In fact, their system actually sat idle because it was staying ahead of their production requirements. And then we had a chance to also work with another customer, and we were duplicating a project, basically making a sister project of a pharmaceutical part of their facility for another customer. And so when I was looking at, they wanted me to duplicate everything entirely. So I was looking at the pieces, and I'm like, do you guys have problems with your CIP? They're like, yeah, it has some issues. I'm like, I'm going to redesign it to do what I think it needs to do so that you can rely on it better. And so that one there, we were able to duplicate it exactly like a sister facility, but I just changed the steps on how the steps were operating on their CIP. Because that one there, their prime problem was that they would clean their tank, but then they would take dirty fluid that was moving through the system and then reintroduce it back into the tank. And so in that case, their answer was dilution was a solution. And they basically had to run that same CIP 3 times for it to meet their quality requirements for a past CIP. And so going through discussions and meetings, I said simply, I'll just use this valve that was there already built in the system and drain out that contaminated liquid, and then handle some other parts of their rinsing capability, washing capability in a slightly different fashion. And they were able to clean that system on a single run reliably every single time.
Wow. Awesome. Jeff, do you have any other, did Hans hit on them?
Yeah, it's always a sensitive topic sometimes, right? Because you're kind of asking them to look behind the curtain, right? To use that analogy, and it's when you start to ask about certain systems, they may or may not know that the system isn't working good, and you're kind of you're asking them to tell you some sensitive information, but once you explain to them that we've had some success like this. So if you think about it, if the system was running at 2 hours and now it's down to 1.5 hours or an hour, think about the savings and the efficiency over a year, right? And so when we talk about like those types of case studies with customers, it has a tendency to lead to great conversations about, hey, how can we look at your facility as a whole and improvements?
Yeah. So, and again, you've kind of mentioned some of these already, but what kind of results are clients seeing that have gone through an optimization of the CIP process?
The big 3 is they save time, they save water, they save chemical, and probably even a 4th one, they save on frustration that they don't have a system that doesn't meet their expectation. And so, and then the other part too is a little less to, put a dollar number to, but then they have the information that they need if they want to use that system in the future for something else, or they even just have it documented. What does it do? And they can provide that information to members within their facility. So if they do have a problem in the future, they're able to say, hey, what does it do? All right, they can look through the information that was provided by doing that deep investigation and come to an understanding and allow themselves to identify that root cause and make that correction internally, rather than always to have to turn external to be able to help identify any type of issues that they might have in their facility.
Yeah, Jeff, do you have any?
Usually these systems, like we talked about, right? There's reporting issues from it, right? It comes from either FDA, there's always the, Food and Drug Administration is always present, and we can help them generate these reports and stay within the criteria of safety, which is the EA. I'll tell you, EHS has a lot of power in these facilities, and if you keep them happy, everybody's happy in the facility.
Yeah. So, and then you mentioned like what they're saving on the water, the time. And they're also, I would say, gaining the additional time to spend more time on production, because they're not having to run the system multiple times, or it is completing the process faster. So all good things.
Yeah.
And then Jeff, you kind of alluded to this a little bit before in wanting to work with the clients in a more partnership fashion and not just on one project. But so I think this goes along with it. But how has the role of system integrator changed in recent years?
Yeah, great question. So a couple things. Most large facilities are trying to do more with less. There's not as much staff as they would like to. So a lot of times they look to partners like us to augment their staff, to take care of projects that they may not be able to do in-house because they're dealing with day-to-day problems or day-to-day challenges of maintenance and engineering. The other thing that Hans can talk to and we've seen this in the last several years, is there's a lot of very, very experienced maintenance and engineering people that are retiring. That part of the workforce that's leaving has all the experience and has all the knowledge, and it's slowly being replaced. But the systems integrator has a place there where we can come in and we don't have to get up to speed in these facilities, and we can act as an augmented staff. But that part of the workforce that is retiring is already a very big challenge for a lot of manufacturers in the United States.
So I want to kind of continue on this. What do you think sets eTech Group apart in this space?
Our goal. Oh, go ahead, Jeff. Go ahead.
Nope, sorry.
Yeah. All right, I'll let you take it first, Jeff.
Yeah. So, what sets us apart? So, because one of the things that we're doing right now, which is our certification for CSIA, not all integrators are CSIA certified. The reason why that is very important is we have to follow a very specific plan. So every project gets a project manager. So the project stays within scope, stays within budget, and stays on a timeline. It's extremely important. Are there times where it goes outside of scope? Yes, there is. But the good thing is that the project manager, the engineers, let the customer know right away that there's something out of scope. Because we're CSIA certified, that makes us have to follow that very, very strict scope, that very strict schedule, and allows for the customer to really, really see what's going on with their project.
Kind of piggyback on that as well, that with CSIA, is a goal of it is that we have a continued collaboration with our customers, our clients, as we go through that project lifecycle. And so by going through that very extensive collaboration where we meet with them on a very regular basis and show them where they're at and get approvals from them, is that we establish a relationship with them. And that's our ultimate goals. We want to have a relationship with our clients and our customers, because then we can know their facility that much better and be able to have suggestions or understand how they're wanting to grow, and then be a partner with them so that they're successful. Because if we can make them successful, then we are successful.
Yeah. So you actually, Hans, are kind of led right into the next one. How do you go about building trust with a client that you're like a new client relationship?
Give us an opportunity and see that, lay out what they're looking for, and have us be able to dive in and look at that part of it. Some of our best successes is the customer just poses the problem to us, right? Hey, I'm seeing this. and then they'll say, we rely on you having that expertise to come up with solutions that we can solve this with. And so then we do that research, figure out where the problem actually lies, what different options are available. Being a system integrator, we're not just stuck on one platform or one method. We're going to look at the breadth out there in the industry and provide them the best as far as economical, the best as far as approach and final outcome, and then lay those options in front of the customer and say, hey, this is our recommendation, but you also have these other options which it might have some level of success to solve this issue. And so that's usually how we have best established those ongoing relationships for our repeat customers. And frankly, our goal is that all of our customers are repeat, that they always come back to us with those and bring us on the very beginning of their developing a project to provide different solutions that might be innovative or allow them to think of what they have not already done within their facility.
Yeah, I would say also just listening to you talk through some of the real world examples you gave where sounded like you were working on something else and were like, hey, actually, how's this work? And maybe we can help with this thing that they maybe didn't even realize was a problem. So I got to believe that would build some trust and confidence as well. But Jeff, do you have anything else to add?
Yeah, this happened just about 10 days ago. A lot of times guys are really busy, right? I mean, the real world thing is everybody's very, very busy, right? And we're kind of not thought of all the time until they're down. I had a customer call me out of the blue. We have a very, very hardworking team that just does services. So we have a 24/7 hour line that is always staffed. I had a food and beverage packaging company that went down. They had 4 vacuum mixers that went down. Our guys showed up on site, did a bunch of troubleshooting, reloaded projects, and got them back up and running within about 3 hours. Those are the type of things where that really builds confidence and trust between a customer and us. I mean, that's the reality, right? The reality is hey, they're so busy they don't think about us until they really need us, and yeah. That's when, right? And those are really good opportunities to build trust.
Yeah, that's great. Kind of going back to some other real world examples, can you give an example of a time where you made with a client, not just in general, but made a small automation change that made a really big impact for a client? Hans?
Yeah, so I had a system where they were looking at trying to re-automate part of one of their critical items for their facility. And so they kind of ran some ideas, and frankly, I got scared by the ideas that they ran by me. So I took it upon myself to research what other possibilities that might be explored to allow them to still get their end goal without me having to maintain some of these very creative solutions. And so I was able to come up with, it was essentially the primary mode within the issues that they were having was a pneumatic ram, and how the position of that ram was maintained properly, and operations would sometimes misplace it and then cause extensive downtime by flooding the area with waste material. And so was able to evaluate what the system was capable of doing with what was already available, and realize we could change the ram into 2 rams of properly specified lengths. And then that allowed them to then go to a set position that then wouldn't overwhelm their discharge system, and then allowed them to develop an actual automated process so that they would just say, hey, we want to discharge the system now. And then the system would be able to just go through required steps and then be in control of exactly where that RAM position was at, and then saved a bunch of times for creating unnecessary downtime. And then also the operators didn't have to sit there and babysit that part of the process. They would just simply select a mode and then be able to walk on to their next requirement. And so I even had maintenance personnel come and thank me later on, because I think they did a lot of the shoveling whenever there was downtime. And also it was very easy for them to maintain this new change to the system because it was off the shelf type of parts.
That's great. Jeff, do you have one or?
Yeah, something similar. We do a lot of work with aggregate, so rock quarries, right? And so when rocks back up, it's very, very heavy and time consuming. And we had something very similar happen where we made a few small changes to the weigh scales and some of the sensors so that the system shut down much, much faster. And there was not that big rock, kind of these rock piles that piled up. And I had a couple guys come up and say, hey man, last week we didn't have any of that rock that we had to clear by hand. So, just small changes sometimes. And I guess we're the eyes that look at a system a little bit differently than the system owner.
Yeah, no, that's a great point. So on the same, I guess, path, but are there any examples that you have of like a challenge that you faced in a recent implementation, and then how did you overcome it? Or no challenges, because we're so great.
Oh, that's why we're in engineering. Love challenges. I don't know if I'm prepared for this one.
So we did a feed study. We did a front-end engineering and design study at a pretty good size construction company. And what that is where we go in and we audit all of their systems and kind of show them a lot of what the systems are and are not doing. And we document the systems, document all the hardware, document all the programs that they have. And we kind of, we'll sit down and go over that front end engineering system and study. And like I said before, right, data doesn't lie. And we kind of showed them this, and they said, that's funny because our guys out in the field, that doesn't happen. They said it doesn't happen. And I said, hey, I'm just showing you what we have. And so we had a challenging conversation with this with this customer, and in the end they were able to go and sit down with the operators and the engineers at this big facility and kind of find out what was going on, and they actually had us come in and correct it. And at the end of the day, the customer was very happy. The company was very happy, but also the facility kind of came around and was very happy. But it can be a challenging conversation because you found kind of something that was going on that you had to pinpoint that may have been a pain point and help them kind of fix. But sometimes it hurts feelings, and sometimes people get, a little bit offended. But, that's at the end of the day, the plant and the facility runs smoother and it saves dollars. And anytime you want to look like a hero to anybody in leadership and management is when you can go to them and say, hey, look, here at the end of the day, we saved this amount of money.
One that I had recently had worked in a very mature system, and it was a system that has gone through multiple iterations of updates and hardware changes, and we were doing the next iteration of that. And because it was such a mature system, there was very nuanced parts of that system that were only discovered by operating it for many, many years. And so as we were going through and making our updates for their latest software and hardware iteration change, we were able to get in contact with one of their really experienced personnel who had seen a lot of this system prior, and sit down and go through and ask them, like, we see this, why did it do this? And then once we understood why, then we were able to then make the decision, well, is it necessary now to keep, or is it something that's gone away because of some of the other changes that have been made in the system? And so be able to go through that and have that conversation, that collaboration, we were able to capture those pieces that were really necessary for maintaining the optimization of how the system ran, and then be able to continue that with their latest platform that system was operating under.
Awesome. Thank you. I don't have any other, I guess, main episode questions, but I want to thank you guys for joining us today and sharing the insights with the listeners. What I would like to do is I would like to end every episode on what I'm calling some fun questions. So what I have for you guys today for the first fun question is, what motivates you to do what you do every day? Hans, would you like to take it first?
Sure. So I love to see things work. I love to be able to push that button and this machine starts to run, and you know, sometimes you're able to see a little nuance, like, oh no, is it going to be able to handle that? I can see it coming my way. Is it going to be able to handle that? And then actually watch the system react better or differently than what I had kind of envisioned in my head. And then a step further, that is when I get to work with a team and then be able to see that team have that same accomplishment as they collaborate with each other, and then be able to bounce ideas off of with each other. Had a project with one of our senior engineers, and he was pushing me to try to make that system better, not for this iteration, but the 2 or 3 iterations that we want to use it for in the future. And he pushed me, and then and it was painful at first, but we worked together and we brought the system. And then when we were able to deploy that, it was one of the best, easiest systems that I've had to work with. And so having that push and pull on both sides to go to a goal and has to work as a team is just amazing, to be able to have that enjoyment and give each other high fives when that project is done, and be able to see something like that work the way it can.
That's great. I love that answer. Jeff?
Yeah. So for me, I have a very short attention span. Every single day is different. Every single project is different. Every single customer is different. And it's just very, very interesting to walk into a facility and be presented with a challenge. And then I get to bring together the team to fix that problem. And I also help manage personalities and the team and the customer. So every single day is different, which is great. It makes it challenging at times. Customers make it very challenging, but no 2 day is the same. And I think that we're getting younger engineers that come in and they realize how interesting system integration and factory automation is. And that's super fun as well.
Awesome. So then you kind of touched on having young engineers come into the company. What's a piece of advice you would give to someone who's just starting their career in automation?
I always tell them, take advantage of the experience that is around you. So ask questions. You don't have to try and reinvent that wheel yourself. There's people around you who have experience, who want to help you, who want to grow you. We don't want you to have the same gray hairs that we endured, passed on to the next line. And also the day and age that we have, the amount of training is immense. And to take advantage of that training that is outside of the company, that's on the web, that's free usually, is take that time to familiarize yourself with some of those trainings. I sure wish I had that amount of training when I first started in the industry at my fingertips.
Yeah, I always tell any younger, I'm kind of part of the alumni network at my university, my old university, and I tell some of the kids that email me, I find a mentor, nowadays it's so easy to go to LinkedIn and places like that and start to ask people what they do. Most people really like to talk about what they do, and it's pretty easy to talk to people and find a mentor. And just like Hans said, ask a lot of questions. People like to talk about what they do, and they're also willing to help a lot of the younger guys, younger engineers, younger project managers, just like that. And it can streamline projects, and it can streamline careers sometimes if you get the right mentor.
Yeah, no, I think that's great. What would you like to see us cover on future episodes of Beyond Tech? Jeff,
this is where you talk, Hans. Okay.
That's so funny.
I think what would be really cool is we've got a couple really, really cool success stories. I think we've got some customers that would be willing to come on with us and talk in a third person as one of the customers that's gone through a project with us, experienced e-tech, and said, from our side, this is the way they saw it. This was fantastic. Working with so-and-so was fantastic. Working with e-tech was really easy, but there was a lot of challenges. And just having like a third person or having somebody independent maybe present a case that they worked through with e-tech.
Yeah, that's a great idea. Hans, do you have any great ideas too?
Sorry, I don't. I've been thinking on that. Okay. I can come up with one.
You'll be on the edge of your seat waiting for him to come out. See what we come up with then. So that is all I have today. Thank you guys again for joining us.